Here we see there's some kind of block at the top of a ramp. The block is going to slide down. Now, typically we expect, since we have a change in height, we have change in gravitational potential energy. Gravitational potential energy, which becomes kinetic at the bottom, unless there's friction. Rest, the top of the length, theta to the horizontal. Block is height h and length L. The block is released and slides down the ramp. The coefficient in the block and the ramp is mu. So there is friction. What is the kinetic energy at the bottom of the ramp? Well, in this scenario, we know that the initial energy is due to the gravitational potential energy. And a little bit later, at every moment in time afterward, we have gravitational potential energy plus kinetic energy plus the work done against friction. And so this is midway, this is the top, and at the bottom, we know that total amount should be the same. The gravitational is 0. And what we know is that the kinetic and the work done by friction must add up to what the gravitational potential energy was. So what is the kinetic energy of the box? Well, we know it is not equal to the mgh because it's not all converted to kinetic. And this mu mgl cosine theta, so force of friction is mu mg is mu times the force normal. And for this, the force normal is going to be equal and opposite. Remember, these thetas are equal to each other. Here is Fg. Here is Fg perpendicular, force normal. And they happen to be exactly equal and opposite to each other. And then there's a component down the hill. So in any case, if we want Fg perpendicular, which is equal to Fn, then the cosine of theta is Fg perpendicular all over Fg. And Fg perpendicular is Fg cosine theta, which is mg cosine theta. That is the force of gravity perpendicular. It is also the force normal. So the force normal is mg cosine theta. So we look at mu mg cosine theta. Mu mg cosine theta is that force of friction. And we want the work done is going to be force times distance. So the force is mu mg cosine theta, and the distance it travels is L. So that is the work done against friction. And if we look at mg cosine theta L, this is just simply the work against friction. Well, that doesn't make sense because the gravitational potential energy is converted to kinetic, except that which is converted to frictional. So that is not the kinetic, kinetic energy at the bottom. And the difference between choices 3 and 4, identical, 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 is this. This one says the potential energy is due to the height. This one says it's due to the length. It is not due to the length, nor is the friction due to the distance of the height. So D is out. Choice C.